Okay, so we're going to talk about solving absolute value equations. So an absolute value is the distance away from 0. So anytime that you have a negative number inside the absolute value, it automatically comes out positive because we can't have negative distance. Okay? A vocab word that you will need to know is an extraneous solution. This is an extra solution. It's a solution derived from an original equation that is not a solution to the original. So basically what this means is that if you solve an absolute value equation, you get an answer and you try to plug it back into the original and it doesn't work, that is an extraneous solution. Okay? So some steps to solving absolute value equations. The first step is to get the absolute value by itself. Now, what I mean by that is you can have stuff that is being multiplied or added or subtracted onto the end of it, and you need to get rid of these things before you do anything else. Okay? The next step is to make two equations. One is going to equal a positive number, and then the other is going to equal a negative number. That is how you undo the absolute value. That is the inverse of an absolute value, is you have to make those two equations. The next is to solve each equation and then check for extraneous solutions. So if I look at this example here, the absolute value of 2x minus 5 is, or 2x minus 1 is equal to 5. First step is get the absolute value by itself. Well, there's nothing being multiplied in front here, and there's nothing being added on to the end. So I'm good there. My next step is to make two equations. So what is inside the absolute value is not going to change. What's going to change is what it's equal to. You're going to have one equal to a positive 5 and one equal to a negative 5. Okay? So then you're going to solve. So go ahead and add 1 to both sides. Divide by 2. So the first equation gives x is equal to 3. If I do the same thing over here, I get x is equal to negative 2. Okay, so these are my two equations. I need to check. Okay, so to check, you just plug them back into the original. So I have the absolute value. I'm going to do one at a time. So 2 times 3 is 6, minus 1 is 5. The absolute value of 5 is 5. Okay, so the first one works. If I plug in the next one here, 2 times negative 2 is negative 4, minus 1 is negative 5. The absolute value of negative 5 is 5, so they both work. This next one, we're going to follow the same steps, but now we have some stuff around this absolute value that we have to get rid of. Okay, we have to get rid of this negative 1, and we have to get rid of this 3. So I'm going to get rid of the negative 1 first. I'm going to add it to both sides. And to get rid of this 3, you can't distribute it in. Okay, it doesn't work like that. You have to divide it out. Okay, I have the absolute value by itself. I make my two equations. One is equal to positive 3, and one is equal to negative 3. Then I solve. Okay, so these are my two solutions. Now I just have to check. So 1 plus 2 is 3. The absolute value of 3 is 3. So 3 times 3 is 9, minus 1 is 8. So that one works. So negative 5 plus 2 is negative 3. The absolute value of negative 3 is positive 3. 3 times 3 is 9. 9 minus 1 is 8. So they both work. So now let's do extraneous solutions. So you'll have an extraneous solution whenever you have an x on the other side. Okay, the process is still the same. So get the absolute value by itself. It is by itself. And then we need to make two equations. Now whenever we make our two equations, you are going to have one positive and you are going to have one negative. So on this side, you just have to distribute that negative in. Okay? Then you solve them each separately. So I'm going to subtract 3x over here. I'm going to do 2 steps in one. I'm going to subtract 5, so that will cancel and that will cancel. 2 minus 5 is negative 3. 4x minus 3x is x, so x equals negative 3. So on this side, we have 3x plus 2 is equal to negative 4x minus 5. So I'm going to go ahead and add the 4x, and I'm going to subtract the 2. So I get 7x is equal to negative 7. Divide by 7. X is equal to negative 1. So now I have two solutions and I need to plug them back into the original in order to check. So let's plug in the negative 3. So 3 times negative 3 is negative 9, plus 2 is negative 7. 4 times negative 3 is negative 12, plus 5 is negative 7. Now the absolute value of negative 7 is positive 7. So 7 does not equal negative 7. So that means that this x equals negative 3 is an extraneous solution. Now you have to check the other one as well, because it is possible to have two extraneous solutions. It doesn't happen very often, but it is possible. So 3 times negative 1 is negative 3, plus 2 is negative 1. 4 times negative 4 is, 4 times negative 1 is negative 4, plus 5 is 1. 1 equals 1. That one works. So this guy right here is your only solution. So now we look at absolute value inequalities. These work the same way as absolute value equations, but whenever you look at the negative equation, you have to flip the sign as well, okay? So if I have the absolute value of 2x minus 1 is less than 5, whenever I make my two equations, I have one positive, and I have to change the inequality along with the positive or negative on the other side. Okay, so then you just solve them separately. Okay, so I get x is less than 3. On the other one, so I get x is less than 3, or x is greater than negative 2. Okay, now is this an and or an or statement? So the way to find out is up here in the original equation, less than, it's an and statement. Over here we have greater Okay, I know I did not spell that right, but if it's greater than, greater, it's an or statement. Okay, so this would be and whenever I solve this one, it will be or. So to solve the second one, I have to get that absolute value by itself, so I divide by 3 on both sides. And then I make my two equations. And I have to change the sign, so change the inequality, and then the negative of -3 is +3. So then I solve. Okay, x is greater than -1. Do the same thing over here. Okay, so x must be less than 2, or x must be greater than -1. Okay, so that's how you solve absolute value inequalities.